Welcome back to my channel. I, Rakshita, currently pursuing BE in Sri Venkateshwara College of Engineering. Now, let's discuss on the topic of critical field and the temperature dependence on the critical field. What are critical field? Critical field invention refers to a development of a groundbreaking technologies that has a significant impact on the particular field or industry. This invention offers address crucial challenges or gaps in executing technologies leads to major advertisements and the improvements. Critical field inventions has a potential to dispute traditional practices in shape industries and the drive societal programs. Critical field and its equation. Critical field, also known as breakdown field, it is a maximum electric field that is a material can withstand without experiencing electric breakdowns. This is a property of insulting materials and the crucial for understanding this electrical behavior under high voltage condition. This critical field is typically measured in a unit of volume per meter, that's Vm, or megavolt per meter, Vm, MV, and Vm. Equation for critical field. What are the equation of this critical field? The equation of the equation for calculating the critical field of insulting materials is given as E, that's critical, V, it's a breakdown, D, where E critical is a critical field and V breakdown is a breakdown voltage and D is a thickness of insulting materials. This equation assumes that the insulting materials has a uniform electric fields distributing and the breakdown occurs when the electric field exists in the critical field. By knowing this breakdown voltage and the thickness of this insulting materials, one can determine the critical field at which electric devices is like to occur. Introduction. Now let's what are the topics we are going to learn. Critical field and the importance of these various significant fields where all the critical field is being used, and the definition of this critical field and the role is determine the behavior of the material. Overview of this temperature dependence on critical fields. This critical field refers to the strength of the external magnetic fields required for inducing the phase transistors in the materials. This marks a boundary between different phases and determines the material responsible to the magnetic field. Critical field is influenced by the temperature, composition, and other material properties. This is a magnetics. This is a magnet where the magnetic field around it is been in the different fields. Measuring critical field. Critical field can be measured using various techniques, including meganewtonmeter and the transport measurements. Meganewtonmeter measures the magnetization of the materials as a function of applied magnetic field. Transport measures determines the resistance or the continuity charge in the materials under the external magnetic field. There is a graph shown where how it's used by a critical field. Temperature dependence on critical field. Temperature in a critical field dependence means it varies from various temperature. In the most of the material, the critical field decreases as the temperature increases. The temperature decreases of a critical field is described by the different models such as a WHH theorem of superconductors. Of this theorem, where WHS theorem of superconductors, which provides a framework of an temperature dependence of a critical field in superconductors. It takes into account that effects of both terminal and quantum fluctuality. This WHS theorem predicts the critical field decreases responsibility with increasing temperature. It consists of mainly two types as type 1 superconductors and type 2 superconductors. As you can see in this picture, This is a type 1 superconductor and this is a type 2 superconductors. Now let's know about the type 1 superconductors. In type 1 superconductors, the temperature dependence on the critical field is realistically simple and the critical field decreases linearly with increasing temperature, where the critical field, when it decreases, and similarly the temperature increases. In type 1 superconductors has a single critical field value about which it cannot sustain superconductors. Where this is the magnetic field and this is the temperature where the superconductors where the critical field decreases linear to the where temperature increases. Type 2 superconductors. Type 2 superconductors exhibits a more complex temperature dependence on the critical field. They have multi-critical fielders including a upper critical field and low critical field. Whereas upper critical field consists of Hc2 and the low critical field Hc1. The temperature dependence on Hc2 is a type 2 superconductors followed by the WHS theorem. Critical field and the high temperature superconductors. High temperature superconductor has a unique critical field properties. They have a separate unique properties. They can exhibit very high critical field, often much larger than the conversion superconductors. This temperature depends on the critical field. In HTS materials, it's still an active area of research. As you can see in this high temperature superconductors, whereas red dots are consist of an oxygen and the green dots are the coppers. Whether this is the dope with holes, where the superconductor are the certain dopings. Application of critical field. Understanding the critical field is crucial for designing and optimizing superconductor materials for the particular applications. This is very main thing that for a designing purpose it's mainly useful. It is used in the development of superconductor magnitudes for medical images, MRI, particles assuming the fusion reaction. Critical field also plays an important role to study about the magnetic materials and the behavior under the extreme conditions. Now let's know about the summary of this critical field. Critical field is a strength of an external magnetic field required to induce a phase transistors in the materials. In the temperature dependence and the variation with the change in the temperature dependence on the critical field is described by the different models such as WHS theorem for superconductors. Effects of magnetic fields. Critical magnetic field, that is Hc. Minimum magnetic field required for destroying the superconductor properties are any temperature. It consists of any temperature. Whereas HO is a critical field at OK. T is a temperature, as you know. Tc is a transistor temperature. This is a graph of a critical magnetic field. Now, at last, conclusions. The temperature dependence on the critical field is described by a Ganberg-Landon theorem, which predicts the linear relationship between the critical field and the temperature. However, this experiment observation has shown derivatively by this linear behavior empirically near this critical temperature. This derivation can be attributed to the presence of impurities, defects, and the fluctuation in the superconductor materials, which affects its critical field and the temperature dependence. Thank you guys. Please do support my channel and please share, subscribe. Please do follow me. Your single likes will fetch my marks. Please do support me.